Hello everyone, welcome to the next program that we're going to see is called as your simple voting system. So let us see the explanation of the code and then we look at the demo. So this code is written using the language called Solidity. So first we are declaring the header. So we are including pragma solidity. Version is greater than 0.8.20. Then we are creating a contract called voting. So we are declaring the candidate names first. So names will be in string, the string of public candidates. Then we need to store votes. So the candidates that we are declaring is written here. So we are declaring three candidates, namely Alice, Bob, and Charlie. So to store votes for each candidate, we are doing the mapping of string uint to 56 public votes, and then we are creating a constructor to initialize the candidates. So we are creating a constructor and we are pushing candidates.push Alice, candidates.push Bob, candidates.push Charlie. Next, we are going to vote for a candidate. So we are using a function called vote. We are declaring string memory candidate public. We are getting votes candidate plus plus. So if it is Alice means plus plus. Whenever we vote for Alice, it will be added. So get votes of a candidate. So after voting, I just need to check how many votes are voted for Alice, Charlie, and Bob. So we are going to create another function called get votes, string memory candidate, public view returns, uint 256. Okay, return votes of the candidate. So this is basically a write function where we are going to cast the vote. So all these are pull functions. Okay, then get all the candidate names. So function get candidates, public view returns string memory, and we are returning the candidates. So this is a very simple program that it is easy to follow. How we are going to see the demo is basically we are going to see the demo using Ganache blockchain plus Remix IDE. So let us quickly get into Remix IDE. So you have to type in the Google Remix IDE. So and then click Remix IDE, launch the app. So once you launch the app, you will be able to see Remix ID is nothing but it is an online ID where you can write the blockchain related codes, or you can call it as a smart contract. The smart contract, we will write the code and we will name the file as voting.sol. Sol means this is written using the Solidity language. So the code that we have just explained here, so I have just pasted here. So the next step that we are going to do is after writing the program. So meanwhile, you have to just go to the, I have already installed Ganache. So you have to just type Ganache and open it. So once you type Ganache and click it, you'll be able to see a Ganache blockchain like this. So Ganache basically by default, it will give you, I think 10 accounts. So 10 accounts, it will be having a balance of either. So you have various addresses. So addresses generally you should not show. But since it's a test blockchain, so I'm just showing. So when you are installing Ganache, so they will give you certain mnemonics that we have to remember. So these are the various accounts that we can see. So what you have to do is when you are opening Ganache itself, you can just go and type. So I have just created a new workspace called Simple Voting System, and I have just created this. Okay, so now let us go to the Remix IDE. So first what you have to do, you have to just compile the code. So this is a called Solidity compiler, where if you just click on the Solidity compiler, you can just give compile. So our code has been compiled. Okay, so once it has been compiled, then what you have to do is you have to deploy the code. So deployment, for deployment purpose, you have to go back here. So there is a deploy and run transaction. So if you click deploy, so it will choose all the accounts. So by default, you can deploy directly in the Remix also. I have showed you already a video for an attendance management system where you can deploy it in the Remix ID. But today I don't want to deploy in the Remix ID because I wanted to connect it to Ganache. Okay, so if I wanted to connect it to Ganache, I have to use the option called custom external HTTP provider. Here you have to give the port number. So let us get into Ganache. So Ganache, here you can see it is running on the RPC server HTTP 127.0.0.1.7545. So you have to go and give 7.45. Okay, once you give that, it will be able to pull all the addresses. So here you can see whatever the accounts that are there in the Ganache, it will be able to pull all the accounts. So if, for example, if I want to use account number 37, so it will show me how many ethers are there. Okay, so for example, I have 100 ethers here. Okay, so now I have not yet deployed my contract, so I have just choosing this. And also here in this, actually, since there is a compatibility issue, for me, when I was trying to deploy, I was getting some error. So here in the advanced configuration, you can just change the setting also. So here in this advanced configuration, here you are using the EVM version as default Osaka. So instead of that, you can go and set it to Paris. So only if you set it to Paris, it is not giving any error, and so you can easily execute the code. So let us see, I have configured account number 37, so it is ending in 1208. So now what you can do is you can go and click the button called deploy. So once you do the deploy, you will be able to see that the blockchain has been deployed. Okay, and here you can just expand this. So it is just saying one transaction was mined and execution was completed. Okay, so it will tell you the status. What is the transaction hash? What is the block hash? And what is the block number? So let me increase the font a bit. So it is telling me the block number. It is telling what is the contract address and also what is the from address. To address is nothing but I am deploying the constructor, right? Then the transaction cost for executing this is a gas amount, the amount of gas that was deployed, and decoded input to 0. These are the logs, raw logs, etc. Okay, so once I deployed it, here I can see the inputs. So where I can give input to the code and I can check my um, the execution. So there is a drop down menu here, no? So whatever the functions that we have written, so these are the various code. So let us see. First, this is the this you can see the color. So this there is an orange color button and these are the blue color button. So orange color button, as I already told you, we are writing some values because I want to enter some words. No, for that I need to spend some amount of gas for execution. All these are pull functions or just display functions like candidates, get the votes, etc. So for all these, you will not be spending any amount of gas for this. Gas is nothing but the ether. Okay. So let us see vote. It is asking for the candidate string. It is asking for the string. So first I will say Alice and I will just do a transaction. So here you can see my transaction got executed and it was mined and it was executed. So now previously we have seen the block number was 6. Now the block number is 7. So for Alice I have entered one vote. So next, for example, if I want to enter a vote for Bob, I can just go and do a transaction. So whenever I write some value, it will be executed as a transaction and now my block number is 8. So here you can see the status, transaction hash, block number, same stuff from address to address and what is the cost, etc. So now let us see. So we have called the first function called vote. Now let us look into candidates. So if you go to candidates, it is asking um, the parameter. So let us say I want Alice. Get candidates. So get candidates, it is saying it is Alice, Bob, and Charlie. So here you can say there is a this is a call function. So here you can see there is a from address to address. So there is an input, there is an output. Okay, the decoded input, decoded output. So it is saying Alice, Bob, and uh, Charlie. Okay, so get candidates are executed. Now let us see the next function. Get votes. So get votes, it is again asking, let us say I have given vote for Alice and Bob. So it is saying for Alice I have got one vote. So you'll be able to see the execution again, because since we are we are just pulling the value. So here you can see there is no gas, no amount of gas spent here. So now likewise let us call Bob also. So Bob also I have given one vote. Okay, Bob I didn't give. So Charlie is here. For Charlie, let us see. Oh, I have not given any vote. So let us see. For Bob, it is saying vote is 0. Okay, like this. For Charlie, it is again 0. For Alice, it is 1. So let me go and both we have seen. Now candidates 0. So 0 means it is Alice. So candidate 1 means it is Bob. Candidate 2 means it is Charlie. Okay, so let us go and put one more vote for Bob and see. Vote for Bob. Okay, so there is a transaction we have written. So now let us go and pull the vote for Bob and see. Candidate 1, it's Bob. Okay, so let us go and check the vote. Get the votes. Get the votes of Bob. So there is one vote for Bob. So meanwhile, I have not shown you how it will be executed in Ganache. So meanwhile, here you can see we have checked this account C1208. Actually, there are 4 transactions are being executed here. Okay, so if you go to the transactions, so here you can see the various contract calls that we have done. Contract creation. So here we have done a contract creation, and there were many contract call functions only that was happening. So here is also contract creation. And if you look at the blocks, here you can see we have mined blocks like 6, 7, 8, 9. So one transaction. So here if you click the block, here you can see the contract creation. So we can see what is the sender address, created contract address, what is the ETH value, gas use, gas price, gas limit, when it was mined. So this is the hash transaction data. So likewise, if you can go and click on each block, block 6, block 7. Okay, the from address was 1208 and the contract address is this. So there was a contract call function. Here you can see what is the gas use, gas limit, mined on, and what is the block hash value. And in the Ganache also, here you can see the account, blocks, transactions, what are the various contracts, events, and also you can see the log files. So here, as and when we execute the transaction, we'll be able to see the logs that are being created by it. Okay. So we have executed. So there was a, so from 7, so you can see with the timestamp it is trying to pull all the details of this blockchain where transaction was created, ETH log was checked in 7:14:57, chain ID was checked, the balance was checked. Like this, you can see all the details here. Okay, so this is how the execution of the contract will happen. So here also you can see at the bottom here you can see the transaction record. So here for this we have created 4 transactions. So if you click the transactions you can see first we deployed the contract which is nothing but the constructor. We deployed 9 months ago. Then we did the voting transactions. Then we did one more vote and then we did one other vote. So let us click on one and just to see. So if you click the constructor, here you can see open in a terminal, you can debug, replay, open in a terminal, open in Explorer. So there are various options. So here you can, it will just take you which transaction it was. So here you can also, these are the various transactions that happen. Okay. So here you have various options like you can deploy uh, Ganache by using various methods. So today we have seen how we can execute Ganache. So here you can see now previously we had 100 ethers, right? So now it has become 99.99. So let us go there also and see. Um, so here it is 99 1202. Let me refresh this and come back and see. Here also it is actually in our remix it is showing 99, but here it is showing 100. Actually it is 99 point something only. Might be since I opened it, it's not getting updated. But here also it will be getting updated as 99.991. So here you can see the address. Okay, it's 1208. So here also it's 1208. But actually this is the exact um, ethers that it is showing. Okay, so this is how you will be executing a simple code using Remix IDE along with Ganache, and how we can test it and execute it. So if you have any doubts, you let me know. So in the next class, we will explore with the various other options. And also here, we have, you can also execute it with the MetaMask. So you can use MetaMask also, where you can export some of the ethers to the MetaMask account, and with the MetaMask also you can do the execution here. So even if you connect with the MetaMask account also, as and when you deploy the contract, you will be able to see the transactions that are happening, and accordingly, like how we can see Ganache also using Ganache, MetaMask and Remix also, you can do the connection. So I will try to show you that in the next video. So I think hope you understood this. Thank you for watching.